Ever wonder how self-driving cars see in the dark or how security cameras spot people at night? It's all about infrared object detection, using heat signatures instead of visible light. But here's the tricky part. Training these systems is like teaching a chef to cook with entirely new ingredients. Most models start with regular color photos, RGB, but infrared IR images are a whole different ballgame. The way they capture data is so different, it creates a modality gap, like trying to compare apples and oranges. This gap makes models unreliable when conditions get weird, like when there's noise, blur, or low light. That's where this breakthrough comes in. Researchers from Canada created two tools to test and fix this problem: LLVIP-C and FLIR-C. Think of them as corruption challenges for AI. They take real infrared datasets and add real-world issues. Think motion blur, sudden brightness changes, or random noise, to see how well models can handle them. It's like putting a self-driving car through a storm to test its sensors. But how do you fix this gap? The team developed WiSE-OD, a clever trick to make models more robust. Here's the idea. Instead of starting from scratch, they combine two approaches. First, a zero-shot model, trained on color images but never seen infrared before. Then a fine-tuned model, adjusted to infrared data. WiSE-OD doesn't retrain anything, it just blends the best parts of both. It's like mixing two recipes to get a better dish, no extra cooking required. And the results? WiSE-OD outperformed existing methods on both benchmarks. It kept the accuracy of fine-tuned models, while adding the resilience of zero-shot learning. This means systems using this approach could spot objects in tricky conditions, like a pedestrian in a foggy night or a car in a dusty storm, without needing more computing power. So why does this matter? As AI becomes more embedded in our lives, whether in cameras, cars, or drones, robustness is key. This work isn't just about better models. It's about making sure those models can handle the messy, unpredictable world we live in. Next time you see a security camera or a self-driving car, remember, behind the scenes, researchers are fighting the battle between light and shadow to keep things running smoothly. Ever wondered how AI handles real-world chaos, like fog, snow, or motion blur? Today, we're breaking down a study that's making object detection models supercharged for tricky conditions. Here's the deal. Researchers tested a method called WiSE-OD, which combines two types of models. One is a zero-shot model, trained on regular images but never seen infrared. The other is a fine-tuned model, adjusted specifically for infrared data. WiSE-OD doesn't rebuild the model. It blends their strengths, like mixing two recipes for a better outcome. They tested this on datasets like LLVIP-C and FLIR-C, which add real-world distortions. Think noise, blur, or contrast changes, to see how well models perform. The results? WiSE-OD boosted accuracy by 18% over traditional methods, even when images were severely distorted. It's like giving AI a backup plan for when the main one fails. Why does this matter? Imagine a self-driving car navigating a snowstorm or a drone spotting a person through smoke. These techniques make AI more reliable in the real world, without extra costs. It's not just about smarter tech, it's about safer, more resilient systems. Let's dive deeper. The study introduced FLIR-C, a benchmark designed to evaluate object detectors under 14 perturbations, including Gaussian noise, fog, snow, and JPEG compression. The key metric: AP50, a scorecard for how accurately a model detects objects. For example, under defocus blur, the WiSE-OD ZS model achieved over 48 AP50, surpassing competitors. But when facing snow or frost, other approaches like LPFT or FT excelled. Here's where it gets interesting. The team tested a parameter called lambda, a tuning knob that balances zero-shot learning and fine-tuning. They found lambda equals 0. 5 worked surprisingly well across most distortions, but tweaking it for specific issues, like motion blur, could unlock peak performance. It's like adjusting your car's suspension for different road conditions. Activation maps revealed how models focus on relevant features. Under elastic transforms, warped images, WiSE-OD ZS highlighted human-shaped patterns, proving it still picks up on critical clues. This adaptability is key. AI isn't just recognizing objects, it's understanding context even when data is corrupted. The takeaway: robustness isn't a luxury, it's a necessity. As AI powers everything from autonomous vehicles to emergency response systems, it must thrive in chaos. WiSE-OD and these benchmarks are paving the way for models that don't just see the world, but understand it, even when the lights go out. So what's next? How will these techniques shape the future of AI? Let's keep exploring the cutting edge of machine learning, because the real world is anything but perfect. Stay curious, and I'll catch you in the next video.